In 2005, at the Mine Health and Safety Summit, the Department of Minerals and Energy announced new benchmarks for upper noise level limits for all mining machinery to be 110 decibels. Such noise level compliant machinery had to be in place by the year 2013. The race was on, and the team now known as Tranter Rock Drills had a major challenge on their hands.
Well, let's begin with the benchmarks. It was the government department responsible for setting the regulations, currently called the DMR, Department of Mineral Resources, who in 2002 came out with the first set of requirements and repeated that again in 2005, that by 2013 no mining equipment should be taken underground that is noisier than 110 decibels. So that was the challenge presented to us as rock drill manufacturers. What can we do to make this machinery quieter? Between 2005 and 2008 we put in a long and involved and expensive research and development program to come up with what we call quiet technology, particularly with respect to rock drilling machines. There's probably no noisier piece of apparatus in any underground mining operation than rock drilling, and what can the machine manufacturer do to make these things quieter. Challenges along the way were, obviously you put in some form of silencer, but does that silencer then impede the performance of the machine? And that's where the point of departure for design and development process begins. In order to have something to test, you've got to make it. So you've got to have a prototype. And to get to a prototype, you've got to have a design. Having designed something, you've got to test it, which then means you've got to have a working model. So you've actually got to manufacture something that you're now going to test. But you'll be manufacturing probably sets of test parts, because at this stage you don't know, you know what's going to work, but you don't know how well it's going to work. So you have a whole variety of test components and test equipment. So you've got to get all that together.
In the mining industry, the concept is probably hindered by the legislation around it. So there's things like weight parameters that needs to be taken into, ease of use, maintainability, and it must fit into the current existing structure of the mine. So because of those, a new concept being brought into line has to sort of conform to those requirements. That forces you, sort of limits you. You can't suddenly design a new thing from scratch. And so that's why even there's new concept, bringing them into life. You already have predetermined parameters that you already have to build into a system. So the biggest problem is trying to make a machine, for example, 23 kilograms of machine. You can't go beyond that because it's too heavy for one man to carry. So because of that, you sort of limiting parameters that can happen.
Having got your test equipment together, or your test model, your working model, you now go into the testing phase.
The process of taking a drawing from the concept to the production to the prototype. From here at Tranter, we've got established test facilities,
which tends to be iterative. You test this, then modify that, then test that, and modify it again, in order to find what only not just works, but what works better. So you've got 10 sets of test parts, of which 3 are the best, then which one of those 3 is the best of that lot. Yes, time consuming and again very expensive, but it results in a satisfactory product.
One of the challenges that we have in terms of setting up a new product, in terms of product development, is that first of all we've got to incorporate it into the factory manufacturing systems. But the first thing that's really important is obviously the availability of the necessary materials. And in some cases where it's got to be outsourced, you've got to get that material, the availability of that material may become a problem.
We've established relationships with most of our steel mills who give us our dedicated steels. Due to our dedicated lines, we've sort of built relationships with some production guys outside who build most of our prototypes, because our lines are dedicated production line for mass productions. And in the industry, anybody who's done prototype would know that to try and destabilize a product line just to do a first off is a costly exercise.
The other one that's very important for us at this stage, obviously, is our quality, safety, health and environment initiatives that need to be incorporated into the manufacturing process. So if it's a product that requires items that requires systems and processes that are outside our ISO management systems, there's a tendency for us to sort of go into a greater depth with that, because we try and avoid being non-compliant, basically.
We've got a test facility to do our first off in-house lab testing. We do have a relationship with some of the mining houses who we do testing for them. That does testing for us. We schedule testing with them. When we get feedback, we do testing. We do test with people like CSIR on patented products like the muffled cylinder, who they've done the testing themselves to get us going.
Within the machine, within the factory itself, you've got to actually assess what you've got in terms of equipment, and then make decisions as to whether the equipment is compatible with the product that you want to manufacture, and what additional tooling and or jigs and fixtures and stuff like that you're going to need to sort of put the whole assembly together. The other aspect, obviously, is the manpower. Depending on the product that you're making, you've got to obviously have the technical competence to be able to make the product that you actually been working on in your research and development. Depending on the product that we're manufacturing, there are several processes doing the manufacturing of a particular product. It will involve several different aspects of machining, which will extend from basic turning, which would be done on CNC computerized machines, into, in some cases, milling operations, again done on computerized machines, and in some cases grinding applications, which are all done on a precision basis. One of the other issues that's involved in the manufacturing process, which is critical to our operation, is heat treatment, and the heat treatment is done within our own heat treatment facility. We have what we think are state-of-the-art pieces of equipment for heat treatment, so we can do the whole range of heat treatment processes depending on what is required within the product itself. And that's probably the major complexities in terms of the manufacturing process.